Greetings, student. This is a recording of one of Garnett's online math lesson classes. You have been granted access to watch this video because you're a paying student and I have seen it fit to provide this recording to you. However, it is important that you know you're not allowed to share this video with persons outside the lessons. This policy is so that my services are kept only to my students. Thank you, and I do hope you enjoy and learn from this video.
We're looking at algebra. And this is solving algebraic equations, I should say, right? Algebraic equations. Good. Now, what I want to distinguish is two things I want you to remember, right? We solve equations, right? We solve equations, meaning that we find for, well, let me don't say we find for, let me be a bit more precise with my language. We find a value for an unknown. It could be multiple unknown, or it could be unknowns. That all right, I'm running out of space here. Let me erase this and write it like this. I'm going to erase and in a sec. Okay. But so to solve an equation means to find the value for that unknown, right? That satisfies that equation. And I didn't need to add in the last part that satisfies the equation, but I'm gonna add it in nevertheless. But in algebra, you solve equations, you find a value for an unknown that satisfies the equation, and we also do what is called simplification, or we simplify, and this is what I believe Rayano was hinting at. We simplify what are known as expressions. Okay? So this is an important distinguish to make. We can only solve equations and simplify. I don't know what it has to do with me, right, Shilio. But yeah, we can only solve equations and simplify expressions. Right? Because only when you're looking at an equation that you can actually find a value that satisfies that equation. We can only simplify expressions. So if you hadn't noticed, when you're looking at an expression, for instance, these long expressions, 5x plus 3x, maybe plus 2 plus 4. This is just a simple example. No need. By the way, you don't need to take what you want down. Again, I just want to bring out some stuff. Good. So this is what's known as an expression, and it's known as an expression because there's no equal sign. Right? Once it doesn't have an equal sign, it is not an equation. You're looking at an expression. All right, good. So once it doesn't have an equal sign, you're looking at an expression. So this is an expression. The only thing you can do here is, of course, add your common terms, right? Like terms. So 5x plus 3x, you know, that'll give you 8x. So you're gonna get, this is gonna be simplified to 8x plus 6. But you notice this is where we stops, 8x plus 6. There is no solving this expression. We cannot actually solve this expression. The only thing that we did is simplify it. right? Instead of having 1, 2, 3, 4 terms, we now simplify it into 2 terms. And that's what adding or simplifying expressions, when you simplify expressions, that's what we're doing. We're just re-expressing that expression, right? You're just changing it up. Right? You're just changing it up in a simpler way. And that's what you do when you factorize, right? With all the factorization that you learned, that's what you do when you factorize. You're just simplifying the expression. You're not solving for anything. If you were solving for anything, then you would know what the value of x is, which is what I'm saying here. Find to solve an equation or to solve even an expression. You can solve an expression. Yeah, you can't solve an expression, sorry. But yeah, to solve an equation, you need to, it means to find the value for the unknown or to find the value for that variable. And you don't find the value for variables if you're just gonna simplify or factorize. So that's what simplifying expression means. It just means that you're re-expressing it or reducing it into a simpler form, either by factorizing, either by grouping like terms and then computing them, adding like adding like terms, factorizing, those kind of things. You're just simplifying the expression. You're not solving anything, right? And I don't want to say simplifying the expression is useless. It's not, right? But it's not the end game, right? It's not the end game. The end game is to solve the equation or to graph the equation. One is the two, right? Either to solve it or to graph it. Use that expression to solve for something. That is the end game, right? So the simplification step, even though it's a question, even though you need to know it, solving an equation is taking a step further by actually finding what the variable or the unknown is. So when you're looking at solving equations, you're just finding for the unknown variable. So let me give you an example. I raised the example with the expression because simplifying expressions is not what I want to focus on today. Solving equations is, right? So I want to give you an example, the example that I gave you earlier. So, okay, I know I'm going to give you that. I'm going to give you a simple example, right? If I say x plus 5 is equal to 9, then I want you to solve the following equation, right? I want you to solve the following equation. It means, okay, right away, all of you should know the answer to this. It means what value, what I'm asking when I say to solve the following equation is what is x? That's what I'm asking. I'm asking what is x? What value, like what value is the unknown, and the unknown is the variable, right? Just keep that in mind. The unknown in an equation is called the variable. So what is x? And looking at this equation, x plus 5 is equal to 9. What is x?
4.
4, right? X is 4, and there are actually two ways you can know this. You can either use maths, you can use your maths, or you can use your common sense, right? You can look at this. If I'm to tell you and ask you a question, I say some number plus 5, because x is unknown, it's unknown to you. So I can say some number or some unknown value. So some unknown value plus 5 is going to give you 9. You could sit down and think, okay, what unknown value plus 5 will give me 9? The only possible answer is 4, because you know from prior knowledge from addition, you know that x plus that 4 plus 9 plus 5 is going to give you 9. Is the only possible solution for x. That is the only possible value that satisfies this equation. And because x is equal to 4, we say this is a solution, right? This is a solution for this equation. It tells us what value is x. So I can give you a ton of equations, and I could even throw in a 2x and a 3x here, right? And then say, okay, this, all right, let me not do that. I could even throw in 2 variables. I could throw in 2 unknowns, 2 separate unknowns, right? 2x plus 3y, and I can say this is equal to 5. Now, again, you don't need to use maths. I'm not giving you guys any complicated equation. But look at these two. Look at this equation. What are the unknowns? If I tell you something, multiply. If I tell you 2 multiplied by some value plus 3 times some other value gives you 5. what are those unknown values? What is X and what is Y? It's staring at you. What would be X and what would be Y?
One.
One for both, right? One would be the case of both, because you can see that, right? If I say 2 times X plus 3 times Y is equal to 5, then you sit down there and think. I don't want you guys to use the maths yet. We'll get to the maths just now. But I want you to conceptually understand what solving an equation means and what's the purpose of even doing it. You're trying to figure out what those values are. You can use maths to do it, or you can figure it out on your own by just using common sense, right? So looking at it here, 2 times some value plus 3 times another value is giving you 5. And the only, again, this is another simple example, but you can see that both will have to be 1 because it's equal to 5. 2 times 1 will give me the 2, so I have 2. 3 times 1, 3. 2 plus 3, 5. So X is equal to 1 and Y equal to 1 are the solutions. You notice if I have 2 variables, I have 2 solutions, one for each variable. Right? Keep that in mind. That is something else that we need to look at. And also keep in mind, and I'm not going to extensively look at it yet. We're going to look at it when we look at simultaneous equations, but you can have more than one values for unknown. Right? You can have more than one values. There are more than one solutions that satisfies an equation, and that can happen. Right? You can have, okay, X in an equation, and I could bring one up. Okay, let's use this, right? If I say some value squared, and that's what the unknown is. X is an unknown value or a variable. So if I say some value squared is equal to 4, again, don't use the maths, think about it. Well, you are using maths, but I mean not to use your not to use your chain historically formula, just to conceptually think about what the solution for X could be. What would be X again? It's not too difficult. X would be equal to
2.
2, right? You want to say 2, but what I can say is actually this is incomplete. Yes, it's 2, but it's not the only. You can ask yourself, is that the only solution for X? Is 2 the only answer that is going to give me? If, well, of course, square 2, you're going to get 4, but is that the only answer? No, correct, right? No, it's not. You can also square -2 to get the answer. So in this case, you have 2 solutions for one unknown, right? So again, in this first instance, you have one solution for one unknown. The second instance, you have 2 solutions, each for the 2 unknowns. And in this last instance, you have one unknown, but you have 2 solutions for it. And that's something that can happen, right? And that's something we're going to look at, right? So when we're solving equations, we're looking at what possible values for X satisfies that equation, right? And you notice I'm looking at singular equations at a time. I'm only giving you one equation at a time. When we look at simultaneous equations in a sec, you'll see that you'll be solving for more than one equation simultaneously, and that's why it's called simultaneous equations, because you're finding for the unknowns for 2 equations simultaneously. And when you guys move on to university level and that kind of stuff, you guys will be solving 2, 3, 4 equations simultaneously, right? So that's another thing. Sometimes it's not just one equation you're solving, but multiple at the same time, right? So again, in a nutshell, what I want you to keep in mind, the takeaway points from these is, now I'm going to show you the math. Of course, I have to show you the math of solving an equation, right? We just conceptually looked at it. Let's move on to actually doing some maths. Now, I don't think I need to explain what are algebraic equations, and I've already explained what is meant by solving an equation. Now, this is just a simple exercise so that you guys can see the difference between equations and algebraic expressions, right? Expressions and equations. I notice all of the expressions on the left-hand side, sorry, don't have equal signs, but the ones on your right do. That means they're solvable, right? it means that they're solvable. Well, yeah, only this one is solvable, actually. Yeah, it means that it's solvable. Let me say that. Yeah, it does mean that it's solvable. So once you have and then that equal sign equal to some value, you could even equal to another expression. Once you have the equal sign, it's an algebraic expression. It's an algebraic equation, which means there's a good chance that you can solve. And again, solve just means you can find a value for the unknown. So this is an example, and this is exactly what I wrote before. Algebraic equations are solved by finding the value of the variable which satisfies that equation. In other words, find the variable, all of which I said before. I completely forgot that they were already on the slide. Otherwise, I wouldn't have re-emphasized it like that before. But it's on the slide already. Right? All these stuff I said before. But let's look at an example at solving the following equations. Now, 5 times some unknown y is equal to 35. You should already know the solution to this. But let's actually do the math, right? We know the math, so let's use it. So if we want to solve for unknown, I'm just going to write back the value. So you want to solve for the unknown. It means that you need to make the unknown the subject of the formula. That's what you do to solve for the unknown, right? So it means that everything else needs to go over the equal sign. That's how you solve for an unknown. So 5x is equal to 35. You should know 5 7 is 35. So you should know x should be 7. But if you want to prove that, right, you can substitute 7 and show that, okay, well, it's equal to 35. Or you can actually transpose, make x the subject by carrying over the equal sign 5. And 5 is being multiplied by x. When it goes over, it's going to be dividing. So carry across and multiplying 5, it becomes a dividing 5. So you end up with 35 divided by 5. So x is equal to 7. So this is you using the math, right? And not just, well, you are, okay, so I don't want to say you're not using the math, because you've been using the math all the time, even when you were just looking at, right? Even when you're just looking at the equation and coming up with a solution. Looking at this, another very easy example, x divided by 6 is equal to 5. Again, you should be able to see that this is 30. X is equal to 30. But again, what it means to solve the equation just means to make x the subject, right? You want to make x the subject, and that will give you what value x is, right? So let's make x the subject. This 6 is dividing, carried over. It's going to be multiplying now. So x is equal to 5 multiplied by 6. So x is equal to 30. Yeah. Right, a few more examples. Now here you see you can't, well, you have to be really good at it to actually see this and solve. But this is another equation. Once it's an equation, we can solve. Right? Once it's an equation, we can figure out what the unknown variable is. So in this case, we have 35a minus 10 is equal to 32a minus 100. And the way to solve this is to group, because we have two terms with our variables, we want to group like terms. Right? We want to group like terms. What does that mean? It means to bring your a terms together and carry across your constants together. Right? So we're going to carry across our 32a. Okay? And this constant mean doesn't have any variable. We're going to carry that across with the equal sign. In short, to invert your operations. So this 32a, it's adding is positive. When it goes over, it's going to be subtracting. So it's 35a minus 32a. Right? Now this 10 is going across. Over here, it's minus 10. When it goes, it'll be positive 10 or plus 10. So we're just going to put 10, and the minus 100 remains the same. Right? So again, this step is just grouping like terms. Once you've grouped like terms, you can compute like terms. Right? That's the point of grouping them. So 35a minus 32a, just subtract your coefficients. 35 minus 32 is 3a. Is equal to 10 minus 90 is negative 90. 10 minus 100, sorry, I'm already shouting the answer. Yeah, 10 minus 100 is negative 90, and 3 again, 3. We're going to carry across this 3. It's multiplying. When it goes across, it'll be dividing. So we end up with negative 30, which means A is equal to negative 30. And again, what does that mean? It means that when that A is the solution for the unknown that satisfy this equation. Okay? So keep in mind that with the examples before, it was straightforward to make the variable the subject of the formula, but keep in mind that you might have to juggle stuff around, meaning group like terms, and then solve and then transpose. Keep those in mind. Now looking at this example, it's a bit different, but you should actually be able to see the solution for this one right away. All right. But if not, again, we wanna transpose. So let's carry the 3A. The group like terms, or just carry the plus 3 over 4 over the equal signs. We end up with A over 4. This is adding. When it goes over, it's subtracting now. So 1 minus 3 over 4. So we just end up with 1 over 4. Okay. If I want to use this, all right, so this is 1 over 4, but I want to use this subtraction to remind you of the subtraction of a fraction, to remind you that the simple way to subtract fractions is to, right, imagine these both as fractions, and to use use the denominator of the second fraction multiplied by the numerator and denominator of the first, and do the same in reverse. So the denominator for this fraction is 1 because it's 1, and multiply by numerator and denominator over here. Doing this will give you 4 over 4 plus 3 times, not plus, is subtraction. I'm sure I would have showed you this subtraction of fractions before, but if you've forgotten, just remember, just for the sake of recall. The purpose of doing this is so that we get the same denominator, right? Because we can only add or subtract fractions with the same denominator, right? And you see you got the 1 over 4, right? So I just want to remind you of that method of subtracting fractions, right? Adding or subtracting fractions. Good, so let's move. Let's move right along. Now we want to make A the subject of the formula, not A over 4. So carry across, you're dividing A. Goes over, it's going to be multiplying. So we end up with A is equal to 1 over 4 multiplied by 4, which if you didn't figure out already means A is equal to 1, right? 1 over 4 times 4 is 1. Right? So A is equal to 1. So all of that just to show you, right? They got some exercise questions. I'm gonna forego giving you guys those, but all of this discussion just to show you that yeah, all of that just to show you that solving equation just means solving for the unknown, and you do so by making that unknown the subject of the formula. Okay. All right, so I'm gonna have to use this guy. Right. Now these notes, I apparently lost it. Good. So this is what we should be covering. I didn't want to go straight into solving simultaneous equations. Well, there are 3 instances where you need to be able to solve it simultaneous equation. But before that, you need to know to identify linear equations, nonlinear equations, and quadratic equations, because there are different types of equations. Right? That's what I'm trying to get into. There are different types of equations, and you no doubt should have known this already, but there are different types of equations. And the three broad categories that they fall under are linear, nonlinear, and quadratic. So I need to get into this, right, before I get into this. So a lot of introductory stuff this session, right, before we actually get into solving simultaneous equations. And the reason why I'm doing all of this is so that, again, bring you back to basics before I bring you forward, right? That's the whole purpose. So carrying you back, I'm going to go through back what are linear equations, nonlinear equations, and quadratic equations, right? Even though you should know this, so that you understand what's going on when you're solving simultaneous equations. So you're solving two equations. Both could be linear, one could be linear, one could be nonlinear, one could be linear, and one could be quadratic. And that's what you need to be able to solve all three, right? All three of these instances. And to do that, you need to be able to identify if a equation is linear, nonlinear, or quadratic, right? Again, we're speaking of equations, right? Now, introduction to simultaneous equations, forget about all of this. What I want you to remember, this is what I want you to take away from this slide. Simultaneous equations are algebraic equations that have the same solutions, which means the variables compute to the same value. Okay, so what is the concept behind simultaneous equations? Why can you solve two equations simultaneously? The reason for that is summed up in this sentence, right? Two equations are simultaneous because the values of x and y are the same in both equations. If that doesn't make sense to you, if I asked you to solve, all right, okay, so if I give you these equations separately, right, and you won't be able to actually solve for it separately, but just imagine, forget that this is here. This is an example. This example is here, but just for the sake of explanation and for the just to make the class go faster, let's imagine that 3x plus 3y is equal to 8, right? And I ask you what is x equal to and what is y equal to. Now, you should already, at least at this point in time, figure out that x is equal to 1 and y is equal to 1. And you know that purely because just by looking at it, 5 times 1 is 5, plus 3 times 1 is 3, 5 plus 3 is 8, and therefore x is equal to 1 and y is equal to 1. Right? Again, the only very simple. Now, if I give you another equation, 2x plus 7y, and I say, okay, well, this is equal to 9, right? Again, you see here that x is equal to 1 and y is equal to 1, which means that for these two equations, what you notice is that x is the same value. In other words, they have the same solution, right? They have the same solution for x and they have the same solutions for y. And those are what we call simultaneous equations. So it means these two equations are a pair of simultaneous equations. So that's what it means when we're looking at simultaneous equations. It means that the values of x, you have two equations. You are looking at two separate equations that, at least to you, look like they don't have no relationship with each other. So two separate equations, but the fundamental concept behind them, the interesting factor about them is that the value for x and y in both equations are the same. And that's why they're called simultaneous equations. And that's why it's possible to solve for them simultaneously. That's the reason why elimination method and substitution method, that's why those methods work, right? Because the value of x and the value of y for both equations are the same. In other words, the solutions for the two equations are the same. And that's what simultaneous equations are. So what we're going to be doing when we're looking at whether both are linear, nonlinear, quadratic, whatever type of equation it is, what we're going to be doing is solving two equations simultaneously by finding that common value, that common unknown, or the common solution for x and y, right? And that's the reason why we need, and you will only see, you'll always see, I don't need to say this. Actually, I'm not going to say it. Not going to bother saying it. I'm not going to say it, right? That's what's happening here. So before I give you this simple example so that you can see the cases with one and one, but in this case, X is equal to 3, so 3, 5 is 15, and Y is equal to 2. 2, 3, 6. 15 plus 6 equals to 21. So that solution checks out. 2, 3, 6, 3, 2, 7, 14, 6 plus 14 is 20. So that solution checks out. So you see, for even these two equations, right? Even for these two equations, they both share the same solutions for X and Y. That's what it means for those simultaneous equations mean, right? Yes, you're solving the equation simultaneously, but the concept behind that is because the solutions are the same for both equations. Good. Now moving forward, moving forward. Now, what I want you guys to get accustomed to is not just looking at the equations, but categorizing them, right? There are categories for these kinds of equations. And there's an important reason for characterizing the equations. It tells you something, okay? Good. So there are more or less 3 types of equations, right? Usually that you'll be exposed to, and mostly 2 of them, right? Mostly 2 of them, more or less 2 of them are going to be your friends at this level. So you're not going to be paying much attention to nonlinear equations, except CSEC will pay attention to it when you're solving simultaneous equations. But otherwise than that, it's not really going to pay attention to it, right? There are rational equations. There are different types of equations, but nonlinear equations, very broad heading. But you don't really pay attention to nonlinear equations unless, at least at CSEC level, unless you're really looking at simultaneous equations. But the linear and quadratic equations are 2 equations that you're going to extensively look at. You're going to look at what they mean. You're going to look at graphing them. You're going to look at graphing them. And you're going to look at solving the simultaneous equation aspect of them, right? So, but there are 3 categories of equations. There are linear equations, nonlinear equations, and quadratic equations. Right? Now, if it's linear, and you can argue that if it's linear, then if it's non-linear, then therefore quadratic is a nonlinear equation. And I won't argue with you. I won't tell you that's wrong. But quadratic equations are so powerful that they get their own category. Right? They got a separate bracket. But it does fall on the nonlinear equations, because nonlinear means not linear. If it's linear and not linear, everything that's not linear will fall on the nonlinear. Right? So just keep in mind quadratics, even though you're separating and telling you there are 3 types, really and truly, quadratic equation is a nonlinear equation because it's not linear. Good. So linear, nonlinear, and quadratic equations are 3 types that you need to, 3 types of equations that you need to be able to characterize. Right? So this isn't important. I just really want you to take down the fact that this paragraph isn't that important, right? At the top, I really just want you to recognize that there are 3 types of equations, right? Again, these are very broad types of equations, and I wouldn't go around saying that there are only 3 types of equations, purely because I know there are more, and this nonlinear equation is really a broad heading, right? But just at this level, for now, and probably for the rest of the CSEC, we're just going to use that equations can fall under 3 categories: linear, nonlinear, and quadratic. You have some examples of each one of those types, and please look at them and recognize and see what patterns you can pick up. The best way, the easiest way to identify them, I'll try to point out those points, but they're best explained with examples, and I'll give you some points as well. So quadratic equations, good. Now, with quadratic equations, right? With quadratic equations, you notice what jumps out at you is that these are squared, right? So let's identify some, let's distinguish between them, and then I'll give you the points. So quadratic equation has a squared x. X is being squared. For linear equations, there are no squared, but you have your x, right? With you have one variable. Okay. You have the highest power of x is 1, right? In other words, there's no square, no greater power than 1. And in this case, with your nonlinear equation, notice that you're multiplying x and y. You're multiplying two unknown variables. With your nonlinear equation, you're either going to add or subtract constants or other unknown variables, but you're never going to multiply them. If you multiply them, then you're looking at a nonlinear equation. So that's really the important distinguishing feature to make. With your linear equations, you're only going to be focusing on powers of x that are less than 1 or 1, sorry, right? Meaning that there's no squared to the third power, that kind of stuff. And nonlinear, you're multiplying two unknown variables. And with quadratic, you're going to be squaring your unknown, right? So I could really give an entire session on explaining what quadratic equations are, what nonlinear equations are, what nonlinear equations are. But that's not the focus of this session. So I'm just going to give you 1 point on the each. Again, something a feature about these equations that you can use to distinguish them from others. So quadratic equations, you'll notice that the highest power of x I'm going to use the word unknown, and the reason why is because I want you to get familiar with actually recognizing that these variables could be it could be x, it could be y, doesn't matter. But the highest power of the unknown, example x, usually x, and example x is 2. All right. So and you have your examples here, right? X squared plus 5x plus 3 minus 3. And you know the highest power of x is x squared. I can argue once you see that x squared, it is a quadratic equation. That's a very bold statement to make, but in most cases, I see you once you see an x squared inside, it's going to be a quadratic equation. If the highest power of x in that equation is not 2, meaning that there's a higher power of x, meaning if they're x to the third power, then it just falls on this category nonlinear. It's not quadratic, it's not linear, it's nonlinear, right? So that's if the power is not, the highest power of x is not, of the unknown or x is not 2, right? Or it's being, x is not being squared. Good, so in this case, we're looking at non-linear equations. Now with linear equations, here, the highest power of x is actually 1. Okay. Or if you want to put it simply, x has no power, right? X has no power, right? And there's none of your variables will have any power, right? If you want to put it like that, x has no power. You can write that down. That doesn't, however it is you want to remember it. But highest power of x is 1, right? Or you can say x. I'm saying x, but it's your unknowns, right? Your unknown. I should be saying unknown, not x, because I'm gonna put I'm using, what is it, second person. No power on your unknowns, right? No power on your unknowns. There's no power on these unknowns. It's a linear equation. Just look for those things. And the chances are, if it's not, if there are no powers on the unknown and the highest power of x is not 2, if it does, if you don't see this or this, then chances are it's a nonlinear equation, right? If it doesn't fall on the linear, it doesn't fall on the quadratic, then just you can always just throw it onto this broad, very broad category nonlinear. But in this, for this example, you see that the highest power is 1, right? The highest power of x is 1, but this equation is still nonlinear. Okay? And the reason for that is because, they're multiplying. The two unknowns are multiplying each other. And another thing I can argue is if you rearrange it, right, you will see, for those of you that are, right, if I change the survey form, I have y is equal to 28 divided by x, right? And this, right, this y is equal to 28, and dividing x can be expressed as x to the -1. For those of you that remember your laws of indices, it'll be expressed as 28x to the -1. And you see here your unknown variable, the power is not actually x, right? The power of x, the highest power of x is not actually 1, it's actually -1 if you rearrange this, right? Good. So you can argue that the highest power is not actually 1. You can rearrange these equations how much you want. You will never dissatisfy this criteria. The highest power of the unknown will always be 2, and the highest power of this unknown in this equation will always be 2. But for this example, if I was to carry across the x, the highest power, the power of x you're going to see is actually -1. So it doesn't fall under these two categories. It actually, and that is one argument that you can make as to why it's nonlinear. Another thing is you can graph it and see that it's not linear. But one to take away is 1.01. I'm just giving you 1 point just to simply so that you can easily remember these categories, is if you're multiplying two or more unknowns. If you're multiplying two or more unknowns, then it's nonlinear. Okay? And if you ever see this, that you're multiplying two or more unknowns, if you're multiplying the unknowns, then it's nonlinear. Or the other point that you can make is that if it's not linear or not quadratic, then it's nonlinear, of course. Okay. Good. So now that you have the note, I'm gonna give you guys a minute to take this down again. You have your note on these types of equations. You can identify them. At least it should be, this is enough. This is enough information for you to identify whether an equation is quadratic, whether it's linear, whether it's nonlinear. And going from there, we're going to solve simultaneous equations. Move on to actually start solving some simultaneous equations. And the first instance is when both equations are linear, right? Now, this is the most common pairs of simultaneous equation you'll see, right? So let's delve right in. Now you're gonna just be doing purely maths from now on. So you're gonna be looking at the solving F aspect. I'm not gonna be going over any concept, just reminding you of stuff, but not going over any concept. So in the case where both equations are linear, and you'll see for the example below, the point to note here is that there are no powers at least greater than 1 on our x, on our variables. I want to say variables are unknowns. So both x and y, notice there aren't any powers on those values, on those variables. So they both are categorized as linear equations. Good. Now, in case like these, where you're solving simultaneous equations where both equations are linear, there are two methods that you can use. One is called the elimination method, and one is called the substitution method. Now I know that especially for those of you who have looked at simultaneous equations before when both are linear, chances are you prefer to use the substitution method. Sorry. All right, chances are you prefer to use the substitution method. But I can argue that the elimination method, what? a massive headache just came in my head just now. I don't know. Yeah, good. I can argue that actually elimination method is the best method to use, right? I can argue, I could sit down and argue with you for days why the elimination method is actually the best method to use. If you disagree, you can disagree, but I will show you both methods. I will show you when you should use the substitution method and when you should use the elimination method. But what I can say right now is that elimination method, it always works. It always works. You don't ever run it. You don't ever run into problems, right? It usually always works, and you're gonna get away, right? With the substitution method, there are instances where it can make your life a bit more difficult if you use the substitution method instead of the elimination method. And I will show you reasons for that and explain why, right? But enough talking. Let's actually look at our first example of solving simultaneous equations, again, when both equations are linear. So the first example, imagine you're being asked to solve the pair of simultaneous equations, right? And remember, we know it's a pair of simultaneous equations. Well, we understand when they say it's a pair of simultaneous equations, it means that x and y in both equations are the same, right? So solve the pair of simultaneous equations. Right? Solve the pair of simultaneous equations. Good. So this is what the question is asking us to do. So let's solve it, meaning when we say solve an equations in one sentence, we know that means we need to find for our unknown values, what is x and what is y, all right? We have x and y, we want to know what those values are. Right? That's what they're asking for us. Good. So let's use the elimination. Okay, let's use the substitution method first, because I know you guys prefer that one. So let's use the substitution method first. And we're gonna use both to solve, but we're gonna use the substitution method first, right? Good. My handwriting is really atrocious. I hope you guys can follow. So we're using the substitution method again to solve for these pairs of simultaneous equations. 2x minus 5y is equal to 3. Now, I'm trying to see if you can figure out what x and y are just by looking at it. Let's see. Maybe you guys figured out? I'm seeing the answer already. If I can, it means you can. It's not that hard. It's not something that hard to do. Any one of you think you got the answers already? We haven't solved anything. We haven't done anything as yet. But can you actually see the answer by looking at the two equations? So some persons are seeing the answer. Good. All right, so let's actually, so keep those answers in mind and let's actually use the simultaneous the substitution method and see if we get those answers. Right? Good. So looking at it, 2x plus 5y is equal to 3 and x minus 3y is equal to 1. The substitution method, the first step in the substitution method, so you can call it step 1, is to transpose right? So the first step in the substitution method is to transpose one of the equations in terms of X or Y. By that, I just mean make X or Y the subject. That's what transpose means, right? To transpose needs to manipulate the equation. Right? So we want to manipulate the equation in terms of X, right? Meaning we want to make X the subject. So pick one of them and make X the subject. Now, the one you want to pick, and this is what I will get into an explanation into why. So let's call this equation one, two equations. You have equation one and equation two. Now you want to pick equation two to make X a subject for. And the reason why is because X, there's no coefficient of X here. X is by itself. It makes solving the simultaneous equation easier, right? So that's a point to take away with these simultaneous equations. When you're manipulating, when you're using the substitution method, you want to transpose, you want to do this first step, right? All right, all right, good. Just keep that in mind. Keep that in mind. Good. So I don't know if you solved it already or anyway. Good. So what we want to do is look at an equation where there's no coefficient on X. And the reason why I'm telling you that is not because you need to do that, but it's because it makes it easy. I can tell you from experience, it will make your life easier if you choose to transpose or make X the subject of the formula for an equation with the coefficient of X, with no coefficient in front of X. Well, meaning that the coefficient of X is 1, right? Good. So we're going to use equation 2. And what we're going to do, like the first step says, is to transpose in terms of X, meaning that we're going to make X the subject. So let's make X the subject. So it says X minus 3y is equal to 1. I can do a better job on writing that Y. There we go. Right? Good. So X minus 3y is equal to 1. And also we can transpose this. We can carry across this Y. And we can see X, this minus 3y, and we can have X is equal to 1 plus the minus 3y goes away, becomes plus 3y, right? So we finished transposing it. That's the first step, is to transpose this. Right? The first step is to transpose in terms of X. So that's the first thing we do. So X is equal to 1 plus 3y. Next step is to actually substitute, right? Step 2 is to substitute. It depends, right? So the next step is actually to substitute. So we created our third equation, right? X is equal to 1 plus 2y is actually another equation, but we created X is equal to 1 plus 2y. So what we're going to do with this equation is to substitute this equation into this first equation. That's the second step. So we have our first equation, 2x minus 5y is equal to 3. And the whole point of making X the subject is so you can substitute it into here. So if we're saying that transposing this, X is equal to 1 plus 3y, then we can actually substitute in X as 1 plus 3y into this equation, into equation 1, right? So that's our second step, is to use the new X equation, or the transpose equation that we would have we would have simplified for, and substitute that into our first equation. So instead of X, we have 1 plus 3y. And that's all I'm doing here is substituting in for X as 1 plus 2y. Why? Because X is equal to 1 plus 3y, right? So having done that, we can actually now solve this, because it has one variable throughout this equation. There's one variable, we can actually solve for this. So let's open out the brackets and solve. So 2 times 1. To open out this bracket, it just means multiply each term by the 2 in front, right? So 2 times 1 is 2, 2 plus, so plus 2 times 3y is 6y, and then we bring back our minus 5y is equal to 3. Right? Now, of course, you always want to group like terms, so this 2 has to go over. We can simplify this. Let's carry the 2 over. It's positive plus 2, addition 2 over here, carried over becomes subtraction, so minus 5y is equal to 3. This 2 goes over, it becomes minus 2. Good. So with group like terms, we can actually do this subtraction, right? 6y minus 5y is equal to y, right? 1y or y, and 3 minus 1, 3 minus 2 is equal to 1. Right? So I can ask those of you that saw the answer at the beginning. Right, so y is equal to 1. So we figured out one of the solutions. Right, we're not done yet because to solve this equation means we need to figure out what both x and y are. Right now, for those of you who would have seen the solution since here by looking at these two equations, I hope that you were able to see that y is equal to 1. So I gotta go to the next one. All right, so step 3. Right, so we found one of them, and that's okay. That's for step 1. And step 3 remain the same for all of them. It's to just substitute Step 2 is just so if you know y, then you can solve. So just substitute in the value for y into either one of these unknowns, and that is your step, your third step, your last step actually. All right, so we know y is equal to 1, right? And y is equal to 1 for both equations, right? Both equations y is equal to 1. So we're halfway done. So let's figure out what x is going to be. And to figure that out, all we need to do is to grab one of our equations. We'll grab again the equation with the coefficient of x being, there are no coefficients of x, meaning the coefficient of x is 1. And you will see that the selecting that equation, the equation where the coefficient of x, or it could be the coefficient of y, there's no number in front there, then it will make your life a lot more easier, right? Trust me. Good. So let's choose this equation and substitute in y as 1. You could pick the other one and then solve, right? So I substitute in y as 1. So y is equal to 1. So in this case, x minus 3, I'm going to substitute in our 1 is equal to 1. Now 3 1's 3. So we end up with x minus 3 is equal to 1. Again, we want to solve for x, which means you want to make x the subject. So we end up with 1 plus 3. The 3 goes across. So we end up with x is equal to 4. Right? So the solution for x is that x is equal to 4. Right? So our answer now here is y is equal to 1 and x is equal to 1. Right? Solution, again, y is equal to 1 and x is equal to 4. So elimination method, what is the elimination method? So again, this is another method to solve simultaneous equations. So we're going to absolutely be solving the same equation and finding the same answers, right? Just a different method. So again, our equation, the two simultaneous equations that we're solving for is 2x minus 5y is equal to 3 and x minus 3y is equal to 1. Right, so 2x minus 5y is equal to 3 and x minus 3y is equal to 1. I put equal to twice instead of minus. Good. So we have our two equations and the elimination method. Step one, I'm going to try and fit all of this into one. Step one is to Ry, I'm going to say X. All right, let me rewrite this. Sorry if you already wrote that down. Yeah, so step one is to multiply the equation. I'm not spelling correctly. I'm not gonna correct that. Of X. Right? So multiply the equations by the alternative coefficients of X. What do I mean by that? It means to just take the coefficient. Okay, let me write this back down here. Let's not touch what's already up there. So we have -5. Y is equal to 3. And actually, no, sorry about that. Let's call that another step. So 2x minus 5y is equal to 3. And you have x minus 3y is equal to 1. Good. So you're going to take the coefficient of the equation, the first equation, and multiply it by the entire second equation, and then take the coefficient of x in the second equation. Again, the coefficient of x here is 1, and multiply it by the entirety of the first equation. Right? So let's do that. So the first equation is being multiplied by 1. So let's multiply every term within this equation by 1. So 2x multiplied by 1 is 2x minus 5y. So let's put the minus, and then 5y times 1 is 5y. And equal to, please put back these operations. All right, please put back these operations. All right, so minus, unless they cancel out when you multiply, right? Good. So minus, well, not minus, 3 times 1 is equal to 3. So that comes back. Let's look at the second one. This entire equation is being multiplied by 2. So let's multiply 2 times 2x is 2x. 2 times x, sorry, is 2x. I might have going ahead. And minus 3y times 2 is minus 6y, right? The minus comes back, negative times a positive, and equal sign comes back, and then we multiply 2 times 1, and that is 2. Right? So these are 2 new equations. So we just created 2 new equations. What we're going to do with them is step 2, right? So step 2 is to eliminate. So can't spell. I can't spell. Grammar vocabulary, everything's betraying me today. So the next step is to subtract the 2 equations. Next step is to subtract those 2 equations from each other. So here we have the 2 equations that are 2x minus 5y is equal to 3. Again, we subtracted the 2 equations that we just created, right? And that's 2x minus 6y is equal to 2. I'm going to subtract these 2 equations from each other. Please subtract them like this. So this is where the elimination part of this method comes in. Okay? Let's subtract these 2 equations from each other. So, and we can only subtract like terms. right? And be very careful with this. We can only subtract like terms. So 2x will be subtracted by x's, y by y's, and constants by constants. Good. So 2x subtracted by 2x is 0, right? We eliminated the x component, the x variable in this equation, and that's what the elimination part comes from. And minus 5y subtracted by minus y, minus 6y, gives us, as you can imagine, positive y. If you can't see this, plus y, right? So plus y. If you can't see this, you can always just write this in a corner, minus 5y subtracted by minus 6y. This is what we're seeing, right? A negative, a double negative will give you a positive, so you end up with positive 6y minus 5y. And minus 5 plus 6 is 1, so you end up with 1y. Right? So that's how we end up with a positive y. So always keep an eye on those signs, right? Keep an eye on those signs. They can be very, very tricky. So 3 minus 2, again, we're minusing these like terms from each other. So over the equal sign, now we have 3 minus 2, and 3 minus 2, again, bring back that equal sign. 3 minus 2 is just 1. So if you see here, you have 0 plus y is equal to 1. In other words, y is equal to 1, because 0 is nothing. So we end up with y is equal to 1, and that's our first solution for these pairs of simultaneous equations. We already knew this before. So the second step, the third step, like before, is to substitute in the solution for the unknown into either equations, right? So this is same as before. So substitute. And remember, I'm calling it unknown just so that you're familiar with that term, but it's a variable, right? Or y. So substitute the solution for the unknown into either equations. Either equations. Okay? I'm saying you can pick any one of the two, and I keep telling you that it's always easier to pick the one with the one where there is no coefficient, or no coefficient. I want to say no number in front of one of your variables. It makes your life easier, right? It does make your life a bit easier. So good, we pick this equation, x minus 3y is equal to 1, and we're just going to substitute in our solution for y, which is 1. Okay. So again, just computing this, 3 1's 3, so we end up with minus 3 is equal to 1. Just transpose, we end up with x is equal to 1. Minus 3 goes up, becomes plus 3. So we end up with x is equal to 4. And therefore x is equal to 4 and y is equal to 1. Okay? So our answer will be y is equal to 1, x is equal to 4. That is our solution, and that is the two equations solved. Any questions or queries?